We have here today with us Charlie Bachman, who's graciously agreed to do an oral history for the Computer History Museum. Thank you very much, Charlie. I think I'd like to start out with a very simple question. What is your earliest recollection of what you wanted to do when you grew up?
Well, I guess the best answer, I don't really think of any early recollection about that. I just kind of grew into it.
All right. Now, I have read that when you decided to become a mechanical engineer relatively early. How did that come about? What influenced you to make that decision, and when did you make it?
Well, I grew up in East Lansing, Michigan, which is in the heart of General Motors and Ford and Chrysler, building automobiles. And so you thought engineers are people who design cars and things that go with them. And that's mainly mechanical engineering. So I just somehow thought that was the general course you took in engineering. If you didn't know what kind of engineer you want to be, you do a mechanical engineer. And so that's what I did.
All right. But did you, what led you to think engineering was what you would like? Were there courses in high school or other influences that led you to say, I think I want to be an engineer?
Well, the only thing I can think of in high school is that the man who taught mechanical drawing was a good friend, and had also the shop teacher and the track team coach. And I was on the track team, although I didn't run very fast. But I had a lot of respect for Mr. Adams and what he did for us. And so probably there's some influence in terms of engineering that came from him and his talking to us.
Okay. I would like to focus most of this interview on your particular accomplishments, but the thing I'm most interested in is not precisely what you did, because that's very well documented, but where did the ideas come from, and how did you end up deciding to do what you did? So maybe I should start with your time at Dow. That was your first job, correct?
Yes.
Okay. Were any of your experiences in Dow something that, or what experiences in Dow led you to start thinking about databases and the IDS that you eventually came up with?
Well, when I started working for Dow Chemical, they assigned me to a job in the engineering department. A big room with 150 engineers and big tables. You could sit on your stool, stand on beside your stool, your fanny hanging out on your stool, and drafting board. It was an engineering school, engineering room. And so when I arrived there, I ended up getting in several assignments, all of which related to information systems, for which I had no expectation. In fact, the first assignment given to me by my new boss He says, I've got 2 valves that are going in a new water line, carrying water out to the far side of the plant. And one water valve costs $5,000 more than the other. And $5,000 then would buy you the nicest big Cadillac you might imagine. And I said, well, I don't understand this. He said, well, one is these are both 12-inch diameter gate valves that open and close. And the difference between the one and the other is how streamlined it is. So we'll take a bigger pump behind it pumping water, or if it's more streamlined, a smaller pump, less electricity, and therefore more efficient. And there was no scheme at that time in the engineering practice that I could find that told me how to compare pumping water through this thing for 40 years versus putting $5,000 more in this valve and saving that money.
Mm-hmm.
And so, as in many ways in my life, I've had to reinvent something because a lot of things have already been invented. So I reinvented what turned out to be discounted cash flow.
Okay.
So 20 years of this extra electricity pumping water, or $5,000 now, put your money down and take your benefit. And so that for the first project was an information system. And then the next project after that was another information system.
Do you have any idea why you got assigned that as opposed to one of the other 150 engineers in the sitting in this room?
Well, I don't really know why I was given that assignment to work for Aaron Brooks, but he was in charge of steam and power engineering.
Yes.
Because the company generated a lot of power and steam for heating processes and power for the electrolytic processes I had. And I guess he had no one working for him directly at the time that I arrived on the scene. So it must be they felt that he needed help. And I had this mixed kind of a background, both business and engineering. Although I don't know if anyone gets credit for that or not.
Okay.
It just happened.
Yeah, but it may have been that he'd seen your resume and he knew that you'd been to business school also. Yes.
Well, so that was kind of a start on it. Now also, part of that question is, if you're going to do discounted cash flow, what interest rate do you want to discount things at?
Okay.
And so I was sent off to Carl Gerstacker's office. He was the treasurer of the company. And said, well, what return on investment do you want? He says, the board of directors decides that. And I said, that's very nice, but the engineers are deciding it all the time. Can you help them? And so we agreed that in the future, each of their big projects would have a target interest rate assigned to it by which we could do this discounted cash flow work. And so when this project was finished and I got off it, Carl Gerstacker called and said, I'd like you to come down and talk to me. And he offered me a job in the finance department doing a real bona fide information system, looking at cash flow in the treasury and how much was invested in plant number 1. We made intermediate products for plant number 2, for plant number 3. For instance, you might think of aspirin as it's a Dow Chemical, but they make an enormous amount of acetyl salicylic acid, which is aspirin.
Yes.
And they said, well, how much investment do we have, let's say, for a ton of aspirin per year as a capacity, or 10 tons? And so I said, well, they said, can you work on that? And I said, sure. So I picked up my few things, belongings, and went downstairs and went to work for the finance department. And in those days, if you solve problems using punch card equipment. So I started working with the people in the punch card department. started collecting all the cash investment things that they had in terms of both, some investments 20 years ago, 40 years ago, and they want to know, well, what return on the original investment, just without any discounting, how much on, if you do discount it, the rate of engineering index has gone down.
Right.
Or, so then I could use that now to calculate how much went into from the salt wells, which are part of the chlorine production system, and the steam and power plant have made the electricity to separate the salt into chlorine gas, which went into monochlorobenzene, which went into salicylic acid, and how much capital behind this.
Yes.
And it turns out that was doing the same as a parts explosion in a manufacturing plant, except it's going the opposite direction.
Yes.
I think it was going more uphill. In a parts explosion, think about start at the top and going down.
Yes, of course.
It's the same calculation.
Okay.
So I was experienced in doing manufacturing structures. And so it took me a year and a half to 2 years, I can't quite remember how much, to collect all the plant statistics from Midland, Michigan, which is the biggest plant, to Freeport, Texas, and to the California plant out there. I can't even think of the town I was in now. But anyway, got all those investment figures to go in and use punch cards to solve simultaneous equations and serial equations.
Okay.
And
yeah, so you learned how to do equations using punch cards.
yes.
Yes, all right.
And I was explaining it to the man who was doing the scientific computing. They had some kind of little paper tape computer. And he said they call that the method of the stupid statistician.
Yes.
And I said, that's interesting. It's got a name. All right, fine. And so that some years later, I said, well, I'd like to find out who did that. So I went on. This is later when Google was alive.
Yes.
So I said, I Googled this expression, Google the expression, the method of the stupid statistician.
Yes.
And I got only one response.
Yes.
That was giving credit to Charlie Bachman.
And that wasn't the right answer.
Wasn't the right answer, but no one else claimed it either.
So the method, just explain briefly, the method of the stupid statistician is?
It's a method by which you start out, and as a first approximation, you say, well, every plant uses its share of the plant behind it. So you get the little extra augmentation to its capital.
Yes.
And you just keep repeating the same cycle. And the numbers get bigger, but they slow down, and they finally come to the point where you can do one more calculation. It doesn't change because you've fully gotten all the capital out of the original power plant, or the salt well in this case.
Yes. So it's the method where you just make a intelligent guess,
Make an approximation.
as to what it is. You see what the answer is. It isn't the correct one. You change that,
Right.
and you keep working back until you've gotten you've assigned the correct variable to the variables in the expression to get the answer that you know is the right answer.
Well, it doesn't change, therefore.
It was when it doesn't change.
You fully devalue.
Yes.
Set the
Okay.
money through.
Yeah. Right.
So that was a big punch card system, which I got involved in, and we had a punch card calculator that did 6 calculations a minute.
Okay.
A 602A IBM punch card calculator.
Okay.
But it worked. So we went back and forth between the tabulator and the collator and the calculator about 20 times to get a number that was not sufficiently different than the one before.
Okay.
Within the accuracy, it has any meaning.
Yes. And then you had your answer.
And my answer.
Okay.
And Carl Gerstacker had his result, and last I heard that method was still being used on an IBM. Not a 709, it was anyway, it's one of their smaller computers.
Okay.
That Dow had
that they now use.
Well, they now use then 20, 30 years ago.
Yes. Okay. Okay. It's 20 or 30. Yes. All right. All right. Very good.
It's a long answer to a short question.
No. The answer often is much longer than the question is. Good. Now, what tell me a little bit more about your experiences moving ahead at Dow. I know at one point they actually were going to purchase an IBM 709. But had you done other computing related projects using their tabulator equipment before that?
No, I had not.
Okay.
But in fact, at this point, when I finished this project on the capital allocation, I was given an assignment in the pricing department to establishing prices for agricultural products, for which I had no algorithm in my mind to know how you price anything.
Yes.
And I did not feel comfortable in that job that I was doing anything useful or I was contributing to what was going on.
Okay.
So I asked, asked the man I was working for, I can't even think of his name at the moment, Baird, could I get a job in production, because I have not worked in production. So he said, sure, why don't you go out and talk to Dr. Schutte, who was the head of the plastics production. And Dow in Midland had a big plant making polystyrene and making saran and other plastic products. So I talked to Dr. Schutte, and he said, sure, we can put you to work out here. So I was given an assignment in the saran production as a process engineer.
Mm-hmm.
Not that I knew much about processing, but I showed up on the scene and spent 3 or 4 months working on a project to improve the drying process on the saran granules after they're polymerized in a water solution.
Mm-hmm.
The monomer turned into polymer granules.
Okay.
And with the proper agitation, you got the right size granule, but then you had to dry it. So I've involved a scheme of a whirlwind, like a silo. You blow stuff in, and I put a lot of air in with it, dried it out, and the dry granules fell out the bottom, and the other stuff flew around inside till it got dry and dropped out.
Okay.
And then opening came into one of the styron plants, the Styron 475, and I was offered the job of assistant plant superintendent.
Mm-hmm.
And this was a big, what looks like a 5 or 6 story building with big chemical reactors and whatnot, and made a form of styron plastic, which for most styron is hard, brittle plastic. But this 475 version, they put rubber into it, dissolved rubber into it, which made it a tougher product.
Yes.
And so it had a big market for refrigerator doors.
Mm-hmm.
It could be colored, as all the plastic colors could be, but if you bump into it with something, it would kind of give out, back out of the way for you.
Yes.
It didn't break the glass or the dish or whatnot.
Okay.
So I went to work out there in that plant for several years. till I got called back again by Carl Gerstacker, which led to the next step in my process, where he called me and said he wanted me to come and talk to Dr. Putnam. Well, Dr. Putnam was these are all doctor this, doctor that, but
Yes, okay.
all out of Cleveland, where Dr. Dr. Dow in the first place came out of the academic world, came to Midland to make bromine from the bromine wells.
Oh, okay.
But anyway, they invited me down to Dr. Putnam's office, who was at that time the general manager of the company
Okay.
and on the board of directors, and he was the president of the company at the time was Lee Doan, who was a son-in-law of the founder of the company.
Ah, okay.
So the family was still
involved in running the company. Okay.
At least as a figurehead. And so anyway, I went down to Dr. Schuete's office, and they said, we're talking down here about getting one of these big new IBM computers. And we want to set up a department to run it. And we think that you'd be the right person to head it up.
Okay.
So I thought that was kind of interesting. And so as we were leaving the meeting, I turned to Carl Gerstacker and said, that sounds very interesting. I'd like to think about it. He says, no, you go to work Monday. So I was seconded.
Yes, you were appointed to that job.
That's right.
Yes.
And so, okay.
All right.
So the next Monday I showed up on the scene and said, where do I sit? And who do I work with? And if that's your job to find out.
Oh, my goodness.
So that was in 1957 was my first time to say I was really in the computer business.
Right.
But the punch card business is the computer business.
Yes.
It's at least the
and it always has been, yes.
Information systems. They have to make decisions, they make calculations. How do you make them with a desk calculator or a slide rule? It's information systems.
Right. Okay. All right. That's interesting. So when you, what did you do? I'm sorry, back up. So when was this computer supposed to arrive? Had they ordered it yet?
No, they had not ordered anything.
Okay.
That was part of my assignment, is to decide what kind of computer.
Okay.
So early in the game, I said, well, I should go visit Sperry Rand, who make Univacs. In fact, they weren't Univacs yet, they were Sperry Rand still at that point, and visit IBM and see what they're talking about and get a little of their education program they have for executives. Although how I got to be an executive quite so rapid, I'm not quite sure.
Okay.
So then I went, first of all, to New York City and went to a one-week programming course there for the Univac.
Was it probably the
1104A?
It was it one of the machines they had done in Philadelphia, like the Univac 3?
No, it was a newer one. This is a Minneapolis machine.
Minneapolis machine, okay. From the ERA group, yes.
1104A, I think it was.
Okay.
So I took a one-week programming course, and then shortly thereafter I went to Poughkeepsie to the Homestead, where they had courses for people that are trying to teach that they should buy an IBM machine.
Mm-hmm.
It was selling IBM and not any particular machine.
Right.
So I went there for my week or 5 days of training. I went back and I was much more impressed with the computer that the Univac showed me.
Mm-hmm.
And so I was nicely moving in the direction of acquiring a UNIVAC 1104A
Yes.
and acquiring a staff to programmers. And we came bouncing up against June 1958,
Okay.
when and I wasn't aware of the U.S. industry that was going on, but there was one of these down pulse, and Dow had a number of years that they were hiring and hiring and hiring, and never had fired anybody. And all of a sudden they had a whole bunch of people. They were getting paid that were increasing their costs, and their revenue didn't match it. And they said, "Well, we have to go back to January '58, and everyone who hired after them has to go."
Okay.
Nice round number. I said, "But Carl Gustecker, everyone in my group, and I've hired 30 people, came in after January 1958.
Okay.
And he says, "Well, we'll make a special rule for you. You have to let half of your people go."
Okay. Oh, that's hard.
And so I looked and said, these people I thought were the best I could find, and experienced people and whatnot. So, but I did the best I could to make a decision. And so I thanked this unlucky 30 people, half of 30 people, 15. And next thing I do, half of what's left were gone.
Mm-hmm.
Said, Dow's not going to do anything soon. We're going to get out of here to somebody else who wants to start in their computer business.
Right.
So we staffed a big project for Chrysler down in Detroit, people,
Okay.
because they were going to get a 709
Okay.
that we had ordered to replace this UNIVAC 1103A when the IBM pressure became such that we wanted to get an IBM computer instead of a UNIVAC computer.
Okay. So IBM talked to at the executive level.
Yes.
And convinced them not to
Well,
follow your technical recommendation.
Right.
Yes. Okay.
So anyway, I was down to a very small group, and I said, well, let's just go to work, see what we can do with the people here,
Mm-hmm.
and learn what their existing systems are.
Okay.
So we got down to a group of 4, 5, 6 people, and with closer allegiance to the existing PortScout people.
Yes.
So I started working, looking at the marketing system to see how we organize things with punch cards to do the things we eventually do almost identically on magnetic tape.
Okay. All right. And so what projects did you work on? What projects did management want to see done on their new computer when they get it?
Well, we got very little guidance from management.
Okay.
They were expecting me to provide the management.
Okay.
But one of the projects that we got into, which I think I made a contribution to, was that there was in the process of building a brand new steam and power plant on the west side. And I had met John Mockley, who was involved in the University of Pennsylvania project.
Right.
And
Now he had left Eckert and Mockley when it was sold to when they sold out to Remington Rand. Yes.
Eckert came to Philadelphia, to Boston. You probably met him there.
Yes,
did.
I remember that.
But John Mockley had a project working with the Navy.
He had become a consultant then.
Become a consultant.
Yes.
and he was helping them design what became a CPM.
Mm-hmm.
It was essentially a system for which you could evaluate how long it takes to get something done.
Right.
And so we had the right position. We said, well, if we knew all the information about how long to do step A and step B and step C and step X, Y, Z, and double X, double Y, Z,
Yes.
then we could figure what's the critical path, CPM, critical path method. And so I went out to start talking to the design engineers and say, well, how long does it take to do this? And they just kind of want to cover up their faces. We don't make estimates. The construction people do.
Mm-hmm.
So the design people didn't claim credit for that job. So the construction people said, well, we know more than anybody else does, but you want to know how long it takes to do job A, job B. That's a kind of a hard number to write down. Can I give you a range of numbers?
Okay.
I said, well, if I were to say, well, with 5% confidence, you can do it. Well, how fast can you do it? And with 95% confidence, can you really get it done?
Yes.
And then what? 50% confidence. So I fitted a Poisson distribution to these 3 points, and I could calculate a formula for it, and then I was reading about things about how to use random numbers. So I'll randomly select 100 estimates out of each job based on its Poisson distribution.
Right.
And so then we ran the Mauchly software solution to calculate the critical path, and you got some numbers, you'll say that were very optimistic. You got a couple of ways you could do it.
Mm-hmm.
And if you went to 95% out here, you could say, well, there's a lot of places there. But people felt much more comfortable using the statistical approach, because it's not a hard, fast number. They say, well, I only had 75% probability here, or only had 25%.
Yes, I understand the construction people, could do that. You could get them to give you numbers that way. You
right.
couldn't get them to give you just one number.
And so I was pleased that seemed to work.
Okay.
And the program that I used to calculate how this Poisson distribution fitted the curve was the first program I ever wrote, and the only program I wrote before I started the IDS project.
Okay.
So I was not quite what you'd say as an experienced programmer.
Yes.
Or I had one successful experience. That makes you very good.
Right. Oh, yes. Now, did you run this? But you wrote a program for it. But did you run it on a computer?
Well, they had a 650 by that time.
Ah.
Out
Okay.
in the plant.
Okay.
So I went out to their 650.
And so you wrote the program for the 650.
One program for a 650.
Okay. Good.
They calculated numbers.
Yes. All right. And that was. Now, did the rest of the program that did the CPM, did you buy that from Mauchly? Had he written that, or who wrote the overall program to?
Well, the actual calculation came from Mauchly.
Okay.
And I don't know whether we paid for it or not. I don't remember.
Yeah, you probably did. I mean, Mauchly would want to get money for it.
Reasonable guy.
Yeah, exactly. All right, very good.
Now, at the same time, this period, which is in one sense a slow period between 58 and 60 when I joined GE,
Yes.
with the order of the IBM 709, we were qualified to join the SHARE organization, which was a group of 701, not very many of those people, 704, lots of those people, and some people with 709s on order. And so I had a chance to go off and get involved. I became the first chairman of the data processing committee of SHARE, because most of them were engineers doing engineering calculations.
Doing scientific calculations on those IBM scientific machines.
Right.
Yes. Now, the 709 had not been shipped yet, right?
Had not been shipped yet.
Yes, okay. No 709s have been shipped
and
yet.
It was supposed to be an advanced machine that could be the replacement both for the 704 and the 705, which was IBM's business computer.
Right.
And so one of the things that showed up at that meeting was a man, Harry Tellier, from GE Hanford, which was the Hanford Atomic Products operation up in the state of Washington, where they were operating the big plutonium plant.
Yes.
Where all the plutonium was made for the atomic bomb.
the Atomic Energy Commission. They had the contract to run that plant. Yep.
And they had an old, he must have been 35 or 40 by then, Harry Tellier, who was running their data processing. And he was a former punch card installation operator. And he asked one of his people, can't we do something? Because it seemed like we're writing the same program over and over again for every report we do. Can't we do something that we just write one program and have it modified in some way? Or so he had one of his people sit down and spend about 3 months to write what became the 705 report generator.
Okay.
And
actually 702, because that's what he had, right? It was a 702 report generator.
702 report generator.
Right.
And the fact that when they were there, we ran the Dow Chemical annual sales reports on their 702 that year. Using their report generator, we could essentially go through and describe what report we wanted on a paper. It looked like what the printer looked like. One column on the paper for every character in the punch card printer. And so I could recreate the reports in a one week visit out there. I could get machine time enough to run the reports and get back to Michigan at no cost to us.
Oh, that's pretty good.
It was good.
That was very cooperative in those days, right?
Well, very cooperative.
Yes. And so you learned about it, and you learned how to use it, and you saw all the advantages of it.
Advantages of it. And so part of the things we got started before I left, Dow, that to start the 709 report generator project.
Yes.
Which became 9-pack.
Okay.
Which was finished about the time that I'd left Dow Chemical.
Okay. And did you do this as part of SHARE? So that
was done as a SHARE project.
Yes. So various companies supplied people.
Dow supplied person, Union Carbide supplied, Phillips Petroleum. Pillsbury was another one. So there was 8 or 9 companies who put a project together, and actually we used a warehouse for an office in Long Island City for those people where they were working full-time away from home.
Okay.
And put together a 9-pack. So I had experience in terms of I wasn't working full-time on that project because Russ McGee took over the project leadership when we canceled our 709 order,
Okay.
because I was not authorized to be a share member anymore.
Right. Okay.
I wasn't a good guy anymore.
Yes. You weren't invited to share meetings anymore. Yes.
But anyway, so I had that experience additionally in terms of writing new. I didn't write it, but I designed programs
Mm-hmm.
and knew what I wanted the report generator to do, and I had, because we had another earlier report generator before it.
Yeah, the 702, the one from
702.
Hanford. Yes. Yeah. So you'd seen what a good report generator, what a good looked like. So
Yes.
that helps a lot. Okay.
So at that time, late the summer and the fall of 1959,
Okay.
I decided it's time that I wasn't going anywhere in this project at Dow Chemical. So it was time for me to find out something. So
Now, had Dow canceled their order yet for the 709?
they had canceled it. Yes, that's why I was left share.
Yeah. Okay.
So I said, well, I'll go talk to GE in Phoenix, where their computer department was. And I'll talk. Well, also this was triggered by a Thomson Ramo Woolridge connection I had through Share to interview there for a job,
Okay.
and then go to Hanford to talk with them about a job.
Okay.
So I made a West Coast trip.
And you had decided that you would talk to how did you know about GE's computer department? Because they wouldn't be in Share. How did you?
Well, GE was in Share. Well, GE was at that time a computer manufacturer because they were doing the Bank of America project.
Right. Yes.
And it had pretty
Irma
good size.
project.
But they also were the largest IBM commercial customer.
So they were both.
They were on
yes.
both sides.
They were on both sides of the fence. Okay. Now I understand.
So that Harry Teller, the manager of data processing out in Hanford, knew about the project in New York, and he run by a man named Ford Dickey,
Mm-hmm.
and he told Ford, you ought to hire Charlie Bachman to go with your project, because it's just what you need.
Okay.
And so Ford eventually got around to inviting me out to New York to visit him because the New York corporate headquarters at that time for GE was in New York City.
Yes.
And so he hired me for the job.
Now, why did you take his job rather than
The others
GE
didn't offer me
computer
a job.
department? Huh?
They didn't offer me jobs.
They didn't?
They didn't.
Thomson Ramo Woolridge didn't?
Well, Thomson Ramo Woolridge said, we can't hire you because you want too much money.
Oh, because Dow was paying you too much.
Well, no, it was too big a jump.
Oh, you asked for a big increase. Okay.
I said, it's too big a jump. We could offer you a job at a lower raise.
Now, were they going to put you in their process control area or just in data processing it?
No, this was their.
Because I know
they were doing
about this.
They were building a computer.
Yeah, they were building the RW300
Yes.
for industrial control at this time.
Well, they also were working on the plans for a commercial
Okay.
computer.
Okay.
And you would know the man who was heading that up. I can't think of it right now.
Okay. Yes.
But anyway, Ford Dickey offered me a job, and we ought to somebody come around and say, talk about the project itself.
Mm-hmm.
Is this a good point to drop that in, kind of in the sequence of things?
Yes. I'm going to ask you some questions about that. I'd just
Okay.
like to finish up on
you go ahead.
the other places you looked. You went to the GE computer department too. Is that correct?
Yes, that's correct.
And what did they do? Were they interested in you or?
Not interested enough to do any follow-ups.
Not interested enough to make you follow-ups or even make you an offer. What happened in Hanford?
I wanted too much money.
Again, there's this too much money theme coming. Did you interview with anybody else?
No.
No. Okay.
So I interviewed with GE in New York.
Yeah. So then you go to GE in New York. And what happened there?
Well, that's where, when I went there, people talking about ISP 2, number 2. Integrated System Project number 2. There must have been a number 1.
Yes.
And the number 1 project, I'll think of the man's name who headed it up. You know him for sure. Went to IBM. But anyway, they did tab-solid table solution, which didn't really go anywhere. And so they worked for 2 or 3 years and really nothing clicked.
Okay.
But behind all this was a man who was the vice president of manufacturing for General Electric. And he thought we needed I talk as GE.
Yes, okay. The GE needed that.
GE needed a generic manufacturing control system because they had 100 manufacturing divisions. And he thought they had 100 different projects going, each one building their own manufacturing control system.
Mm-hmm.
At great expense and low probability of success.
Yes.
They had both experiences, too much money and not enough results.
Right. Okay.
And so he thinks we ought to start over on this project. So the project was to create a generic manufacturing control system.
And it was named had it already been named ISP2?
ISP2.
At that point?
At that point.
Okay.
And Stan Williams was in charge of it. He had come out of the power transformer division.
Okay.
And he'd come down to New York and was trying to put the project together.
Okay.
And so I came and climbed on board.
Okay. Could I ask one question?
Of course.
Now, so this was a corporate group that oversaw all of manufacturing for GE. I understand GE was very diversified in the sense that the plant managers were, had a lot of autonomy to go do their own thing. So what was this? This was an overlay or sort of
this was
organization?
A group that looked at generic problems.
Ah, okay.
And did consulting.
All right.
But they didn't do a lot of development of their own.
Okay. All right.
So this is a new thing that, bigger computers were new things.
Yes, at that
time. New
time.
tools, new opportunities.
Mm-hmm.
So this group, the only people there were people who had either been hired for the ISP1 project. One of the men was still there from that project. When I joined the ISP2 team, I was the last man in, so to speak.
Okay.
And I was told some people since then that I was hired to be the chief architect. I don't know if that's true or not, but I know I was the chief architect.
You quickly figured out that
I was the one.
That nobody else was going to do it, so that's what you were going to do.
Yes.
Okay.
So that we had, in fact, Stan Williams and myself, and Bob, whose last name I can't think of at the moment, all from Production Control Service, which is one of the staff groups located in New York City.
Okay.
The three of us were full-time on the project. The rest were all someone from the engineering department, engineering staff, part-time. When you can find some time, work with these guys. Same thing, someone from accounting, someone from marketing service, someone from purchasing service. So we had a bunch of people who would come to meetings once in a while, but they weren't workers in the normal sense. You couldn't schedule them or assign them anything.
Yes.
So Stan and I were really the principal workers,
Mm-hmm.
and did most of the work. We kind of divided the work as we got along the way. I was kind of chief architect, but also I was chief programmer.
Okay.
I'm working on my second program.
Now, when you got there, had they come up with the concept of the MIACS? You know, did they have an outline in their heads about that, or
Well, no, they had
how much had been done on that?
They had 5 letters: Manufacturing Information and Control System.
Yes.
That's what they had.
And they had nothing behind it?
Nothing behind it.
All right. So there was no concept of that and operating as an application with a database or any of that?
No.
Okay. I just didn't know how far along they were. They just knew that they wanted to come up with a generic system.
They had basically had acquired a team,
Mm-hmm.
three full-time people and a bunch of stringers who were consultants. That's their
Yes.
job.
Yes.
And that's where they could help consult on their part of the manufacturing process.
Right. Okay. So what did you do first when you got there? What did you and Stan?
Well, first,
What did you have to figure? What did you have to figure out first?
well, first thing we had to figure out is where's our laboratory? I don't mean laboratory like toilet. I mean
Yes.
laboratory where you do research work.
Right.
And we needed a GE department who's willing to have us come and spend a lot of time with them to figure out how they ran manufacturing control.
Mm-hmm.
And so Stan made some trips around and had been making trips looking for someone who's willing to expose their business to corporate staff.
Yes.
And you
Which
have to understand that's
I
touchy.
understand that is dangerous, and you don't do that if
That's
you can get
touchy.
away with it.
But we did get approval from the man who was head of high voltage switchgear department
Okay.
to invite us to come down and use his business as a laboratory
Mm-hmm.
and set us up with a office facility across the little old grocery store across the street where we could set up some desks and whiteboards and whatnot. They weren't whiteboards, they were blackboards in those days.
Yes.
And people could come over to have meetings. And this was at 69th and Elmwood in Philadelphia.
Okay.
There was a big old manufacturing building there, which is 7 or 8 stories high and a block square. The whole block, 7 stories high, that was both high voltage switchgear, medium voltage switchgear department, and also a small low voltage switchgear department.
Okay.
All of them living there, and it was high voltage switchgear that signed up with us. And so we started going out to come to. When the first visit we went, I was just walking with Stan and the other people through the plant that high voltage was using and just pointing out various things. And I remember going into the machine shop, which was one whole floor of this building, where they made parts which got put together to make the high voltage be up to, I don't know, 1 million volts or something, very high voltage
Mm-hmm.
circuit breakers for power transmission lines.
Yes.
And I noticed a bunch of tote bins, what I was told to call it tote bins, a steel box about that big by that big, about that deep, full of parts, and with a bunch of punch cards wired on the end of it. And I looked, and these punch cards were described, might say, cut off, drill this way, grind this, do so. You're fabricating this piece of raw stock into something that, and the raw stock got cut into length someplace else and was delivered to where the next machine operation was.
Right.
And I noticed, I looked at these cards, they all had not only an order number on it, but they had a date on it and an operation to be done. And so it was a piece of a manufacturing plan on this. Each punch card was a whole wad of punch cards all wired together.
Mm-hmm.
And each machinist would take one card and do his, and put the rest back in the wherever it was standing, maybe standing on the floor someplace or on top of a radiator. In fact, we talked about it being radiator storage.
Yes.
Because everything is covered with tote bins in process.
Yes. Okay.
And I looked at this and I said, well, some of these dates have already gone by and they hadn't done it yet. And I said, well, this is the plan that was made by the computer. And so once an order came in, they computed a plan to make it and punched the cards out and sent it off to whoever was doing the first operation on it.
And the cards just kept going along.
Kept going along and being taken
in the
off.
bins, yes, as the stuff moved.
And so, but the thing is that the dates on it are irrelevant.
Right.
Because if anything went wrong, there's no way to fix the plan.
Yeah.
And this is one of the first major learning points on my part. Because when I was in the Army, in the Anti-Aircraft Corps, we had anti-aircraft guns, 90 millimeter guns that we aimed at Japanese airplanes over along the coast of New Guinea during the war. And I knew that these guns were very accurate, and the computer was a mechanical computer, physical computer. It was on it like a card table on three sides. This thing is a box with an analog computer that could look at an airplane through some telescopes on it and could aim it. Here's the airplane there, and somebody decided turning this wheel, which made the thing rotate on a vertical axis, and on this side turning it made the elevation change. And so their job was to get this thing aimed at a Japanese airplane and then keep the crosshairs on the Japanese airplane. And this mechanical computer would say, I can see you here, I can see you here, I can see you here. Therefore, in 15 or 18 or 21 seconds, you ought to be there. And so our guns would be automatic change, and we'd fire them, but the airplane wasn't there, it went off someplace else. And so the thing I observed is that we had guns that were very good at shooting at a sock being towed behind a target plane.
Yes.
For practice, and we were very good at hitting them. But in my area of the war, we weren't hitting anything with our anti-aircraft guns. But then I said, oh, their bomb sight is assuming they were going to fly straight too. So they weren't hitting their targets. They were dropping their bombs, they were making a lot of noise, and we were making a lot of noise. But we weren't doing a lot of damage.
Yes.
Either of us.
Yes.
So I said, well, that's the same problem that these manufacturing control systems have. They fire a shell, a pack of punch cards, they went off into the factory, and regardless of whether somebody made a mistake machining something and had to start over again, or whatever it might be, or they didn't have the machine available, it got off schedule. No way to rename it. So they had a bunch of men called expediters who would pick up the deck of cards and say, now I'll go here, I'll talk my way through the shop and see if we can't catch up on it. And as they frequently found out, the customer would call in and say, where's my order? Before the shop figured out they were not on schedule.
Oh.
So they were a little embarrassed about the situation. And so they wanted a system that would get it manufactured on schedule, or at least would tell them that they're not on schedule.
Mm-hmm.
And so I was thinking about, well, how does the anti-aircraft people or people shoot airplanes down now? Well, they use Sidewinder missiles. And Sidewinder missiles aren't very smart. They say, I can see you, or I'm coming at you.
Yes.
Oh, you moved. You moved again. And by then I've caught up with you.
Right.
Boom.
Yes.
And so the Sidewinder missiles with a very small computer, minimal logic that I can see you, and I can aim at you. I can steer myself,
Yes.
and I can fly twice as fast as you can.
Right.
And the Sidewinder missiles were very successful.
Right.
Our 90mm guns, you could shoot at a flight of airplanes. You might hit somebody,
Yes.
but you wouldn't hit the target.
Yes. Okay.
So that was like we have to do something about this system. Because this plan that I had with all the punch cards was made in a computer, or IBM, not an IBM, but a GE 225 computer they used. Made punch cards. So it wasn't the computer's fault. It wasn't programmed to have any way to call the cards back in again. And
But
fix
there
them
was
up.
no update, real-time updating. There was no way to do that.
No real time. It's just at 1 second of real time, but then in their case it might be 3 months or 6 months out,
Yes.
and no way to catch up.
Yeah.
So I said, well, we need a system that when a plan gets off schedule, we can reschedule it.
Mm-hmm.
Even we have to go back and tell the customer, I'm sorry, we're going to be late. At least the customer knew we knew it was going to be late.
Right.
So that was the first design thought.
Okay.
This thing has got to be real time.
Okay. And iterative.
And yes, iterative.
Iterative. Yes.
And so we could do that.
Okay.
So that was the first thing. Then they said, well, how do you do this update? Well, that was the time when the big discs were just coming out. The discs were new. IBM had what they call it,
They had a RAMAC.
a RAMAC, yes.
Yes.
One
Okay.
disc on a computer,
Yes.
which,
Now, is GE at this point planning? Because you probably had to use GE computers, didn't you?
we were planning to get general purpose computers.
Yeah.
And they had it. Well, the 225 computer, which we worked on, was a general purpose computer. It was you might say, a smaller IBM 704
Mm-hmm.
or a smaller 1104A, which are very similar machines. They're von Neumann machines.
Yes.
This is just smaller in the sense it had smaller memory. You could have it in 8K words or 16K words, those are your choices. In comparison to the 704, you could have 32K words.
Right.
In the same sense, it was a little bit slower.
Yep.
And it was a junior computer.
But it was a core memory machine. It did have core memory,
It
right?
did have core memory.
Yes, it wasn't a drum machine like the process control computers that they were developing at the same time.
Or the 650 was a drum computer.
Absolutely. Yes. Okay.
So they were wiring those boards by hand out back in the plant.
Yeah. Okay. So, all right. So you have you've got to make this iterative. So, what do you remember? Sort of what were your next thoughts as you worked through in your mind how this had to be organized or architected?
Well, the next thought went through my mind is that someplace in one of the computer journals, and I've never been able to find that issue. I thought it was one I was writing about artificial intelligence, but it wasn't the IBM group, and it wasn't the MIT group.
Mm-hmm.
But it talked about list processing.
Okay.
I said, well, we could do list processing on a disk. And I had read someplace else about the Ferranti Atlas virtual memory.
Ah, yes, the paging in the Ferranti Atlas.
They call it a backing store.
Yes.
That's how we got to be an integrated data store.
Ah, so backing. Yes.
From the backing store.
Okay.
So this became the data store.
Okay.
So before we had databases, so the Ferranti Atlas was clear rooted because it was the new thing on new kid on the block. So much because you could write programs bigger than your computer.
Yes.
And you could bring pages of it in at a time. And I said, well, we could just do that for the database.
And you could do it automatically, as opposed to the old way. I mean, people had been doing that, but they had to structure the program and bring in one piece of it, do that, and then under program controls say, all right, now we need the next piece, and move.
But that's not a virtual memory, though.
That's not automatic, and it's not automatic.
Not automatic.
Yes, where you don't worry about moving the program. The programmer doesn't worry about moving.
No, that's not true.
Yes?
Because in IDS there are things you can do to cluster things opportunistically.
Ah.
So if you want to store a purchase order, you want to store each line item record in the same page.
Oh.
So you bring the purchase order in, you get the whole order in.
Yes.
So in the database administrator's job, there's some tools by which you can enhance the performance by clustering things in a way that will respond to the most likely uses of the data.
Okay.
But if you have some other uses very different, it'll just run slower.
Yes, okay. Very good, very good.
So
so anyway, let's roll back.
Automatic.
I think we got off on a tangent here. Yes. So you knew about disks.
Knew about this.
And you knew about
Virtual memory.
Virtual memory. And
we also knew that virtual memory, in the case of the RAMAC, well, not virtual memory, but the fact that IBM tended to use a block of data from the tape or from the RAMAC, which was one logical record.
Mm-hmm.
And it turns out if you're randomly selecting things from blocks that have only one logical record, and as you're going to load things randomly, you're very quickly going to get to the point where you have duplicate things randomized to the same block number. So then you have to go to an overflow, put it someplace else. But if you make a block big enough to handle 50 records, then you could maybe operate your disk at 80 or 90% physical capacity without getting excessive overflow.
Mm-hmm.
So I did some studying of how the numbers worked and said, well, if we're going to use blocks, and Univac used blocks on their tapes too.
Okay.
IBM always used a logical record was one physical block.
Okay.
Which meant that their 705s ran slowly. 702s ran faster because they had a 200 character buffer, so they could have a 200 character block if they wanted to. So you got a real lot of useful data in of it.
Yes, and you were going to say.
I was going to say that we're talking about how close to the frontier of availability of disks were.
Okay.
Well, it turns out that when we were ready to try to run IDS to make sure it was running, to do some test execution, we did not have a disk available. So we used two magnetic tapes to simulate a disk.
Oh my goodness.
We just created a tape that had 64 blocks on it. And so, which block do you want? You want block 10? Okay. Copy 1, 2, 3, 4, 5, 6, up to 10. Okay, there's the one you wanted. You want 11? That's easy. That's right behind us here. Oh, you want number 5 now. Oops. We got to go all the rest of them over and then come back. 1, 2, 3, 4, 5. And we got perfect functional equivalency.
Okay.
Very, very slow, but we
Very slow.
But we could test it.
Okay. That's very good. So you
we
figured out a way to actually run, though very slow, but with all the logic in the program working the way it was supposed to.
And working, it was doing its job.
Okay. So now talk to me a little bit about the manufacturing control system. You sort of had to figure out how that was going to work. Did you figure that out before you figured out how to do the integrated data store, or did they sort of did you work those out to get all together?
Well, in the first year of the project, from January to December 1961, I had written the complete, quite detailed description of what IDS was, how it worked, and I had rounded up a bunch of data processing managers at GE who we call friends of IDS to look over my shoulder and critique it as I went.
Mm-hmm.
So they could see what's going on and bring their experience to bear on it. So we had such things as the virtual memory, the clustering, the randomization, all those things are all laid out in place. And we had actually just created a way at the meta level to store that information so we could record it.
Mm-hmm.
And we had some very funny looking drawings that we made at that point, which are a very early version of the data structure diagrams that we used later on.
Mm-hmm.
But they were really ugly. They were helpful, but they were ugly.
Okay.
But the first year we had, and we went back took our team back to Philadelphia, to high voltage switchgear, and had the corporate staff, vice presidents, several of them come down to listen to this presentation. And of course they didn't have, we made flip charts in those days.
Yes.
In fact, I thought they were quite artistic. I would love to have saved them.
Mm. Okay.
I would have loved to.
Oh, yes, but you didn't. Yes, you couldn't.
I thought about it, but I didn't know how important they could have been.
Okay.
Although they're in the program that we did for the Computer History Museum on IDS some years ago, I had a couple of these flip charts I had photographed. So the one of the pigeons and the pigeonholes, if you ever remember seeing that.
No, I don't.
Did you ever see that that lecture I gave on the assembling IDS?
I think I did, but it's so long ago I don't remember it clearly.
But anyway, we had all the management team there, including the general manager of the high voltage switchgear department, and he had invited his medium voltage switchgear department counterpart and also the low voltage switchgear counterpart. And I think he was thinking ahead, because at all said and done, he said, well, this is all very nice, but I've got other things to do. I'm not going to continue the project. So this is my department, and I've spent a year with you, and thank you for letting me do it, but I'm done. And fortunately, the low voltage switchgear general manager said, I'll put his hand up and said, I'll take it over.
Okay.
And so the first department that was actually up and running in was the low voltage switchgear department.
Okay.
And he furnished, that general manager furnished his top systems people to help bring their knowledge into the project.
Okay. And you didn't need to move because they were all in the same building.
They were all in the same building, and we were still in the office across the street,
Okay.
which has worked out fine for us.
Yes, very good. That's excellent. So did you have to get authorization at some point to really implement this, or from corporate, or was that one of the purposes of this sort of meeting after a year after you worked it out?
Well, well, at the end of the first year, it's a question: do we go forward, and how do we go forward?
Mm-hmm.
And we didn't go forward in high voltage switchgear. We moved to low voltage switchgear.
Yes.
Fortunately, there was someone there who was prepared to take the risk.
Okay.
Because people tell stories. I remember talking about one of the general managers down there who didn't fix the roof of his building that was leaking because repair work would come under current expenses.
Mm-hmm.
And would affect his P&L. So they just mopped up around the leaking roof and didn't invest in fixing it because he was bucking for the next job up the hill, which meant based on how good are you at making him a profit.
Mm-hmm.
So there's a lot of things that the general manager had a lot of responsibility. In fact, his main responsibility was making a profit.
Mm-hmm.
He couldn't set his own accounting scheme because counting was done centrally.
Oh.
So the counting people did not report to the production division. They reported to corporate head, who had a standard accounting system for everybody,
Okay.
so they could compare people.
Right. And so he couldn't fudge the accounting by deciding to do it a little bit differently.
Well, he could put off the job.
Yes.
It was fixing the roof.
Yes, he could do that sort of thing. Yes. All right. So could you, one of the things I wondered whether you could maybe describe in layman's terms, so our general audience could understand it, what the integrated data store was, and a little bit of how it worked.
Well, first of all, one of our challenges is we wanted to do something that the average, or let's say the good programmer in the field, could learn and become proficient in quickly.
Mm-hmm.
So people were used to being programming at the record level, the financial programmer people.
Mm-hmm.
And so they'd do patch processing of records sequentially. I said, so I want to preserve the programming milieu so that you need a record, you issue a command that will bring you a record, and there's your record just as if it had come off a magnetic tape, except it's now going to come off the disk. And how it knew to get off the disk is what's hidden back here you don't need to worry about. So that we provided a language, basically said, well, we have records, and we have one other critical, three things. Records had relationships with other records. So if I look at a purchase order has things about a customer. So there's a relationship. We have customer records and purchase order records. And each purchase order has line items that people are going to buy. Well, the same thing they would have if they were buying it and we're recording it on magnetic tape. Well, it's going to, on a disc, it's going to be together again. When you bring those in, you can bring in one record at a time, bring in the record header, then you can bring in the order header, then you can bring in the line item 1, line item 2, and so you arrange your processing to process all the items until you're done. Then you essentially know what the total of the bill is.
Mm-hmm.
And you go back and update the header of the thing. So that we were trying to make it comfortable for the programmer. Now, in terms of access, we had the ability to anything which had a primary key, whether it's a purchase order record or an employee record or a factory machine type record. If you knew the primary key for that record, you could just say retrieve primary key, or excuse me, you take that primary key you have and put it in the location for what the primary key for a purchase order record is called purchase order number.
Mm-hmm.
And then you say retrieve purchase order record. And that would just that very brief command, it would go and look at the purchase order number and use that number to use whatever rule the database administrator applied to this, and go find it based on the primary key and bring the record in, and the programmer knew it's right there for him.
Mm-hmm.
And the fact that you had to go down through maybe 10 levels of subroutines to get to actual physical storage of it, and bring it back through the subroutine levels and deliver it to the working storage area of the program, where you would have gotten it off a magnetic tape also.
Okay. Could you tell me in layman's terms, what you perceive were the advances over previous ways of doing it, that the integrated data store allowed users to accomplish or to do?
Well, I think the most significant factor about IDS comparison to, say, all prior art was that it was designed to be a system that was adapted to many different targets, to many different applications. And it was not a one of a kind. And everything up to that point, whether it was a American Airlines travel reservation system, it was a one of a kind program at great cost. And the experience they had at GE, they had a few systems that were maybe hand tailored. In fact, our first performance test against somebody else was to take IDS and take 2 weeks to write the programs that we could run against that made the same thing as the people in Ohio were running on their laminated products. And they had spent 2 years of hard labor trying to get something that would give them their disk-based order entry system. And we were talking to the GE in-house consulting group, and they said, well, this is the best we can do. It's really a sharp system. I said, well, we think we can do some of the same thing. It shouldn't take you 2 years. And so Stan Williams wrote his first IDS program in the 2 weeks' time that emulated the application that the laminated products people were developed. And Bill Helgeson, who was a really old, tough guy, a nice guy, but a tough guy, said, if your guys are just half as good as what we did, we'd rather do it your way because it's so much cheaper to have a quick installation than to have to program it the way we programmed it. And so we ran a test, and not that we run half as fast, we ran twice as fast as they did. And they said, how'd you do that? And I said, well, we use virtual memory, and we do this and do that. And they said, well, we don't know anything about those things. And I said, well, what we've accomplished is the ability to have a database system, a virtual memory system that you can use independent of the application, and you can apply it because there's a data manipulation language you use that merges right with GCOM, which was the early version of COBOL. And you can use it and run it, and you don't have to spend your life on it. And so I think the most important thing about IDS is it was a system that was amenable to being used many places. And the history of installation, the first year IDS, we said, well, it's good enough to use. So 2 different GE departments, not the MIAX people, but the GE International, IGE, installed it for their order processing thing. And Wiring Devices Department, who make little wall switches and things, down in Providence, Rhode Island, they installed IDS, and they were up and running that year. Within the year it was first released. And how well it had been debugged before that? Well, it debugged as well as I debugged it. And it was pretty much bug-free. Because when you have only one programmer, you can see the whole thing.
Yes.
Now, we had 2 programmers. We had Homer Carney, too. So everything, virtual memory down is Homer's territory. And so Homer had full control over that. And I had full control over virtual memory. So tell me where that record is, and I'll take it from there.
Okay.
So it's the generic solution was the key, most important part of it.
Good.
And this included the transaction control part too, which is one of the less known parts of, was it part of IDS or was it the problem controller as we talked about it?
Mm-hmm.
Because you have to have something that will allow you to instruct the operating system, the transaction processing system really, which of 20 transactions or maybe 1,000 transactions you got backed up that you can run now based on the business's requirements. And so another business might have a totally different set of transactions which are important versus not important. Now, one example of this thing is that when we first released IDS to the GE inside customers, the problem controller would say you can have various classes of problems. Transaction type 1, type 2, type 3, type 4, type 5. And if there are type 1 transactions, process those first. If there's none of those, you process the second one next, and the third one next. And that worked nice, but in the second year we were running, Weyerhaeuser Lumber, who were the first non-GE user, said, this is very nice, but we want to shift our priority from day to night. And then shift it back the next day. So there are some transactions that are very important during the day, but because the results can go back to the sales office, it's open. But at night we don't worry about what they want back tomorrow. We want what someone else wants back tonight for shipping purposes. So they inserted it. Well, they corrected a system design flaw that I'm guilty of. Something I've been told before many times from punch card days, that you never use a data field as a primary key if it's functionally meaningful. If it's just a number, it's unique, then we can find it based on the number. But if it has to have a meaning, like both a unique problem code, but it's also the third level of priority. What if you want to make it the fourth level of priority? So you should never, that's a bad thing to do, to make one data field try to serve two purposes. And people do it all the time. So Weyerhaeuser added one more field to the transaction master record. That was its priority number, so at night they could reshuffle these cards again and run it all night long, and then tomorrow they shuffle it back the other way. But the ability to have a transaction control system that can respond to business requirements, and it took them, well, probably 2 days' time to make what would be a fundamental change to someone's hand-coded system.
Okay. Good. Well, I think that's a good, in some sense, that's really a good summary of, what the fundamental advances were in the system. Can you talk a little bit now about the history of the system? It was originally set up to run, so you can put statements for the system into the GE compiler, sort of their own version of COBOL.
Yes.
Compiler system.
Pre-COBOL.
Pre-COBOL, yes. You eventually changed the system because of some of the computer requirements to run this. That it took the largest machine that GE made at the time, and you switched to an interpretive system. Could you talk about that and that transition and the thinking? What happened there? Tell that story.
Okay, well, when we first developed IDS, it's more as that you started out as a COBOL programmer or as a GCOM, which is a General Electric Compiler programmer. And we added commands that allow you to store and retrieve and modify and delete records in this virtual memory. But modifying records and storing and deleting was not very unique. So we did that in a very standard looking way. And so that I set it up so that, first of all, you could take your description of your data and code that and actually store it in the IDS database. What we would have called a data dictionary if we had thought about it. So there's data dictionary which had all your description in it, and then you put your store, retrieve, modify, delete commands in your COBOL program and ran that program against the database with your data description in it. And what it would do, it would take each of these IDS commands and expand them into more GCOM language, or in some cases into assembly language, which GCOM couldn't handle the function. And then you put that whole thing through the GCOM compiler, then went through the assembler. You had a program that was inline coded to do exactly what you wanted.
Right.
And nothing else.
Okay.
For that program.
Right.
Some other program would have access different records, different functions. They get expanded. But even the point, if you had two different places in this program, you stored the same kind of record, it would look and say, well, I already expanded this once, so I'll package it in the program going out as a subroutine that I can call either place in the program and get the result. Well, the GCOM compilers tend to be bigger than assemblers, and so GCOM compiler used the maximum size GE200 computer, which was 16K words. And there were smaller words at that. They were 20K words.
20-bit words, yes.
20-bit words. And that also was considered by many GE departments as being very expensive to get a big GE200. So we want a smaller one so we can save money. And they were tight kids. And so they said, well, can't you... Bill Helgeson, this guy who was a tough guy before, said, we'll buy it if we want, but I want you to reprogram it as an interpretive system. So that you have all the subroutines you need to do all the store, retrieve, modify, and delete. Just you have to give it now the data dictionary at runtime. So you can say, I want to store a payroll record. Okay, then the payroll record's got all these structures in it, and it'll expand to store the payroll record based upon what it needs. If you say store purchase order record, it'll generate it'll interpret a different code. Yes. But based on the same subroutines that are record generating. And so that was run in an 8K machine, which was a great thing to have happen, except that it turned out everyone bought a 16K because I get more paging buffers in a 16K machine than I can in an 8K machine. Because the interpreter is still the same size, the program is still the same size, so that they all wanted to buy 16K anyway, and so I spent a year reprogramming that whole thing. Because that's the second program I wrote. Okay. And so and it turns out, you know, I had not heard of Moore's Law. In fact, I looked up in the book the other day. Moore's Law was not spoken until 2 years later. So how do I know that I can get twice as big a memory next year and everyone thinks it's a bargain next year and this year it's too expensive? Right. So that I often wondered whether things were taking a different course if we'd stayed on the inline coded version. But to my knowledge, all of the versions of IDS and its lookalikes still run interpretively. Okay. Because it's clear how you do it. It's the way Charlie did it last time. Yes. Okay. All right. So that was a progression in IDS. At the time, the IDS originally was just used in GE departments. You mentioned Weyerhaeuser was the first people who, outside of a GE department, that wanted to use it. Talk to me a little bit more about the evolution of IDS as a programming, as a product within GE, and then I'd like you to talk a little bit about who the competitors were and what happened in that world, and especially what IBM did. Well, in the evolution of IDS, the GE200 version of it, which is the one I wrote, both the inline coded one and the interpretive one, was for the GE200 line of computers, the 215, the 225, the 235. And there was this junior-sized computer in comparison with the IBM 704. There was coming along at that time with two other computers, GE400 and GE600. GE600 was much closer to what a 704 or what a 709 became in terms of being a 32K memory, being a 36-bit word. And IDS was programmed both for the 400 line and the 600 line. And that's the first place anyone except Weyerhaeuser got access to it. Okay. Well, that's not quite true. B.F. Goodrich Chemical in Cleveland were a GE 225 user, and they got a copy of it. They got one box of cards.
Okay.
So 2 boxes of cards, 4,000 cards.
Okay. But that was essentially the limit of it at that point.
That's important because that's what they reprogrammed us for the IBM 360.
Oh.
That's how IDS escaped into the IBM marketplace. So you could go to Cullinan database systems and get IDS, except it's called IDMS, Integrated Data Management System. And depending on how close how you leave people, they weren't close or they were close. But I have some of the manuals from it came out of the
Goodrich? Did you say B.F. Goodrich or
B.F. Goodrich reprogrammed it for the 360, and then that was taken over as IDMS by Cullinan. And when Cullinan ended up hiring more people than they could pay their salaries, and so they weren't making money, and their stock went boobs.
Yes.
And they were actually bought out by people down in Long Island.
Yes, the Computer Associates.
Computer Associates, or CA. They took over IDMS.
Yes.
And in fact, I sent off to the Charles Babbage Institute some tapes I have, which shows that their data formats on the pages are the same as I designed.
Oh my goodness. Wow.
So there's a lot of similarity there.
Yeah.
And they didn't understand some things when they recopied it, so they've split some things I joined together, so it's lost a little power. But anyway, the B.F. Goodrich escape with the 200 was one early non-GE user of IDS.
And so they did it for the 360. Do you remember about what time? That they must have done this sometime after 1964 when the 360 was announced.
That was done. I don't know exactly, but let's put it late 60s.
Sometime in the late 60s, yes. After 360s were shipping.
After they were shipping.
Okay.
And after B.F. Goodrich Rubber Company, which is a parent of B.F. Goodrich Chemical, said, we're going to standardize on IBM.
Okay.
And so they said, you can give up on IDS if you want to, or you can reprogram it for us on the 360. And of course, anytime you program something in a different interior decor program machine, you're going to get the coding is going to look somewhat different. Different programmers have different styles, but obviously IDMS got some other things they copied from IBM to give them a broader marketplace for IDMS.
Okay. So was this put into share so that any IBM installation, 360 installation, could run IDS?
No, you couldn't do that because the 360 version was a product owned by B.F. Goodrich, which they licensed to Cullinan, which eventually transferred the license, and the rights went with it.
Okay.
Okay.
So that's the history of how it got to Cullinan. When did Cullinan get it? Do you remember what year I don't remember when Cullinan started.
I don't remember.
Yeah. Okay.
And then as soon as it was up and operating, really two IDMSs in GE one year, and the next year 4. They went up almost double every year for quite a while, adopting the 200 version. And in the meantime, back in Phoenix, where the headquarters for GE Computer Department were, they were reprogramming it for the GE 400 and the GE 600. Although they were done by 2 different teams. But at one point, I said, look, we have to have the same randomization algorithm. So when you can move a database from one computer to the other, and the randomization works the same. So if you're doing that randomized storage and retrieval, you don't lose that capability by moving from a 400 to a 600.
Yes.
And the rest of it's protected by other software.
Okay. All right.
But the 400 and 600 were sold for a long time. In fact, if you go to Google now and Google up what is Honeywell, and Honeywell is not the Honeywell it was before that bought the GE stuff.
Right.
But it's a aerospace company that bought Honeywell, but kept the name. And there's still IDS education classes going on.
Really?
At Honeywell, at least they were last year.
My goodness, that's cool.
A few years back, when the Charles Babbage Institute was earlier in its life and had not quite settled down yet in Minneapolis, where it is today, they had a trustee group that kind of helped in its funding. And I went to a meeting they had in San Francisco or the Bay Area. And I met a man there that I didn't know, but I knew his father, who had been one of the share people from the University of Michigan. Was probably the head of the computer department at the University of Michigan. But his son was head of the IMS department at IBM. And we were talking about IDS and IDMS. And he said, well, he was managing the IMS group, and they still had 4,000 IBM mainframes running IMS worldwide. And I had previously heard that IBM, can't say it, Computer Associates.
Yes.
I went to one of their user meetings. I had user meetings.
Yeah.
Still having user meetings.
Okay.
And they said they had 1,000 IBM mainframes still running IDMS.
Oh my goodness.
And if you look at the largest transaction processing systems in the world, they rank number 2 or number 3, which is British Telecom, which is now BT.
Yes.
And I had a chance to call on them, and they're still running IDMS. I don't know how many hundreds of thousands of transactions a day.
Wow. Because
if you have a tough, demanding, performance-oriented system, there's nothing better. And I think we've proven you can't do a hand-carved one and get it better either, because you don't know enough of all the tricks.
Yes.
So IDS as IDMS is still 1,000 of those, plus there are Honeywell machines still running it. The banking system in general in Norway runs it, or online banking.
Wow. That's pretty good. That really is. Now, what was IBM's, did they eventually come up with an answer? What did they do?
Well, there's a yes and a no to that question.
Okay.
In the 1960s, IDS came in. In the very late 60s, early 70s, IMS came out of the aerospace industry. There's an index sequential oriented information management system, IMS, which they said was good enough for them. They didn't need an IDS.
Mm-hmm.
And if they're still running 4,000 of them against 1,000. Of course, they're a lot bigger organization than Cullinane.
Yes. Right.
Bigger marketing group.
Yeah.
And their final solution was to go to DB2, a
Right.
relational database system, which does some things nicely. But it's the fact that people have migrated in masses for their major system. The major systems are still sitting on IMS or IDMS
Mm-hmm.
because they were the best of their class that were offered to their customers.
Mm-hmm.
And so the long life things for things, well, things that are running well, leave them alone.
Yes.
Don't fix it.
Right. A well-known engineering thing. If it isn't broken,
Don't fix it.
don't touch it. Yes. Good. Good. I have a couple of general questions I'd like to divert to right now.
Okay.
Yeah, and then we can go back a little bit more in to the historical mode.
Okay.
Okay. Who during your career would you say were your role models?
I don't think there is a person that comes. There's some people that I worked with that I feel were very important, and they're contemporaries of mine.
Mm-hmm.
Russ McGee was one of the people that came out of GE Hanford and became the chair of data processing chairman after I left. And he and I worked together on various things a number of times, and I always felt I'd learned lots of things from Russ McGee.
Okay.
And Stan Williams, who again is a contemporary. In fact, the three of us are all within 1 year of the same age.
Oh my goodness. Okay.
That means we're all, well, Stan, if he was living, would be 90 now. I'm 90 now, and Russ will be 90 later this spring.
All right.
But those are my closest compatriots, and role models, I'd say also, in the sense I felt like I could always learn from them.
Okay. All right. Good. Another sort of general question. Looking back, what were the turning points for you in making your life decisions that sort of led you to where you are?
Well, I think, go back to your words, where I made my life decisions.
Yes.
It seems to me in most cases, the situation sees me instead of my seizing the situation.
Okay.
I kind of rolled with the blow as I went along, and maybe some of the things like when I said I signed up, I didn't sign up, I just went and took Wharton School classes on the daytime with no official authorization. I just registered for them.
Okay.
Because
you were free.
I was free.
Daytime, and you were curious.
And I didn't make the opportunity. It fell on me in spite of myself.
Yes, okay.
And so leaving Dow Chemical to go to the project for ISP2 was a situation where I had inquired around the GE network I knew about and didn't find anything, and didn't take the job with Thomson Rainbow Wooldridge. And so that Harry Tellier called a friend in New York, said, "You ought to hire this guy." And he came and got me.
Okay.
And the jobs that came up at Dow Chemical were kind of came there, and I guess I may have done things that made other people select me for a job.
Mm-hmm.
Oh, in fact, one thing we haven't talked about at all is the data communication work I did with the Open System Interconnection Group.
I want to get to that, but yes, definitely.
It's an example of an opportunity that kind of came up, and well, I think maybe I maneuvered that one more than any other one, because when they were going to form this new international committee, the ISO SC 16 committee, the Honeywell staff group back in Minneapolis said, "We're not going to spend any time on this." And I had been working on communications more than I'd been working on databases at that time at Honeywell. So I thought we should get in on it. So that what I did, the man who had been helped us on the IDS codicil work that we haven't talked about yet,
Yep.
but from U.S. Steel, who's one of the codicil committee people. And I said, "Well, if you nominate me as chairman of the SC16 committee, the Honeywell management probably would be too embarrassed to say no." And that's exactly the way it worked out.
Very good.
That's how I got into be the chairman of the International Standards Committee,
Yes.
number 16.
Okay. All right. That's good. So another question, a generic question, is what is your biggest regret in terms of decisions you made?
Well, the discussion we had about the interpretive versus inline coded one is a real clear case of a decision we made, which we know is not a bad decision. It worked.
Mm-hmm.
And the other one was intellectually more advanced, because everything was buried by compilers and a lot less manual fiddling around, because we had to regress back to assembly language to get it in the 8K machine. So that was one of the decisions I always wondered whether that was. The other decision that I think an opportunity that I didn't appreciate at that time is that in terms of what I've talked about as being the problem controller of the operating system for transaction processing was a late bloomer, so to speak, because we had been working with one of the GE divisions, the aerospace division, and they were going to build us a little small, compact transaction processing operating system. And when they said, "Oh, it's ready to go now, it's got between 2,000 and 3,000 instructions," and we said we only allowed 4,000 for everything. And then we just said, "Well, that's very nice, but thank you very much." So only in the last year did we get around to worrying about what we were going to do for an operating system. I said, "Well, an operating system, this is like a store and forward message system. And we got to store and retrieve and forward. Yeah, it sounds like a database problem." So the problem controller stored the transaction database records, transaction records, in the database along with everything else. And we just treated it as another subroutine to call. And it called it, loaded the data, selected which transaction type to use, picked the first transaction of the transaction type, loaded the program that went with it, or if it wasn't already loaded, and turn over control of it and get out of the way. So we had our operating system, transaction controller, is probably less than 70 instructions, because they're all IDS instructions. Because we're storing and retrieving records, and we're not looking inside of the records.
Yes.
So it's just one more thing to store and retrieve.
Mm-hmm.
And the other thing that came along with this, because it was being done with IDS, that if you had an application program that needed to create a new transaction in the transaction world, it's all the data descriptions there you need to store a transaction record with all of its data.
Mm-hmm.
So the way we handle level structuring in the parts explosion was that we just start the highest level doing parts explosion, and it would leave a record of the next thing in order to explode, and actually had a transaction code that was slightly not as good, so we wouldn't get to it until after we got rid of these guys. So I later said, well, why didn't we, let me stop here for a moment.
Yes.
No, and the question here says, why didn't we go back to GE and said, when you're doing IDS, we appreciate what you're getting along with it. And I'm not sure how much they ever knew about it, or because I lost touch with that work group.
Yes. Okay. But in a sense, that's a regret that they did not, that you didn't sort of point out to them and sell a little bit what it was doing and how important it could be.
It was a big thing to do transaction processing, because people were having to hand code transaction processors.
Right.
And here you got one off the shelf.
Right.
Well, because this is what Weyerhaeuser took that thing and fixed it so they could change the priorities.
Right.
Day to night or over the weekend.
Yes.
And talking about storing forward in this thing, the transaction, that once I had a visit back to Weyerhaeuser to see what they were doing, and they said, we had a funny experience. We had a point some months earlier where the orders flow was going up, and they were getting more transactions coming in. And they were getting enough transactions so that when the Monday transactions have been processed, and at the end of the day, it's ready for the next day's transactions, there were still some leftover transactions from Monday. And on Tuesday, there was more Tuesday transactions left over for Wednesday. And so that these orders, which are pretty important to the business, were getting pushed down in a push-down stack.
Mm-hmm.
And so that when you got around to Friday night, they got rid of their highest priority things. And then they started working off this backlog of things. Yet in the meantime, all these things were being backed up on orders. You could get a new customer code for a new customer from the system in a matter of a few seconds, because its priority was always higher than an order's priority.
Yes.
So this thing would back up enough orders so it took them until sometime on Sunday to work them all off.
Yeah. Wow.
And this, one thing about this that drove the operators crazy is that 635 computer that Weyerhaeuser had in its operations center had no local I/O devices on it. No card reader, no punch, no printer, no typewriter. It just sat there and ran. And it drove the operators wild. How do we know it's doing the right thing?
Yeah.
How come, what if I'm on a loop here? I'm doing on a loop.
Yeah, that's right.
We have loops all the time. Well, the IDS didn't have loops. And so they said, well, what we'll do, we'll take a IBM electronic, whatever those IBM typewriters are.
Yeah, selectric
typewriter.
Right.
And we'll program, so what's an hour? It reports the length of the queue. And so what's an hour? You go look at it, it goes, okay, that's different than it was last hour. It must be, it's okay. We leave it alone. Because they want to shut it down because they didn't know what's going on.
Yes, okay. Yeah, they were afraid it was, gotten into some loop. Yeah.
Oh, one thing that fits in here at the moment,
yes,
added in, Weyerhaeuser was a very aggressive information processing group, very aggressive company in the lumber business.
Okay.
And so it didn't take too long before staying up all night on Sunday to get your work out was not a very happy solution, because what happens when Sundays run out of time and you're in Monday?
Right. And you still haven't gotten the last week's work
so
done.
they wanted a version of IDS they could run on the new 600s. So they'd have the bigger computer, and the 600 had some extra memory capacity and whatnot. And they said we want it also so we can run transactions in parallel, shared access to IDS.
Okay.
So we put together a team of GE Phoenix people with Weyerhaeuser Tacoma, Washington people, team operating up in Tacoma, Washington. That Russ McGee, who I've mentioned, is one of my, I started the project, he took it over.
Yep.
Russ always has a hard drive. He has the deliverables.
Yes.
And I can wave my arms, it's easy.
You could just, it's like the architect. You don't have to build the building.
That's right.
Right.
Don't have to worry about it. Well, anyway, they got it running, so they ran multiple transactions. It did deadlock detection. It did, if you got a deadlock, it'd back everything out, and rearrange the sequence and start it up again. So it automatically recover and restart, which ran for years until they finally got the IBM itch. Well, Honeywell was by then taken over the company, and they didn't have the same faith in Honeywell they did with GE.
Right. I don't think Honeywell supported the 600 series the same way.
Well, it was still being done in Phoenix.
Yes.
Called a 6000 now.
Right.
But anyway, that was the first shared access database also in the industry.
Very interesting. Okay.
And in fact, one of the interesting things we learned from it, they programmed it because they said, we don't know whether we want to lock memory for when it's somebody says, I want to access something. Do I lock it at the logical record level or lock it at the page level, the big block level? And it turns out if you lock a block, because you're locking actually one record in it, you got upwards of 60 records locked, and so you get more deadlocks. Some of which are not real.
Right.
Well, the deadlock's real, but the cause is not there.
It didn't. Yes, logically, it didn't have to be deadlocked, but the hardware worked that way.
That's right. Hardware worked that way.
Okay.
So that they say they ran it both ways, and it turns out that you get far fewer deadlocks were operating at the logical level, but the system ran slower because you got a lot more stuff to search to decide whether we got a lot more units were locked. Because somebody might have this page locked, but he's got a purchase order with 10 purchase items on it.
Yeah.
Which might be on 10 different pages.
Right.
So it turns out they end up locking at the page level because that's got the greatest production, because that's what they wanted. As long as it's going to stop and recover itself, it just stand back, guys, and stay out of the way.
Whatever goes fastest is bestest.
Fastest is bestest.
Yes.
Right.
Okay. Very good. Okay, I have a few more generic questions. One is, what were your most important life lessons?
Most important life lessons.
Yes.
Let me think about that one. Let's go on to the next one. I'll come back
Okay,
to that.
very good. What was your proudest moment?
Proudest moment. I guess when I got married.
Very good. Okay. Did you have...
Let me tell you a story.
Okay, you're going to tell me a story about that. That's good.
Well, just a bit about that. But when the first child arrived, it was Chandani who you've met.
Yes.
And we went out to, this is back in the days when fathers were not allowed anywhere near the delivery room.
Mm-hmm.
You could go look through the glass to the room where the babies were. And the doctor went in and reached down with his two fingers out like this. And Chandani grabbed, this is my first daughter for those of reference, this little baby girl with hanging on two fingers, and picked her up out of the crib like that and said, when they're first born, the first day, they'll hang on and they won't fall. Now that strength goes away very quickly, but he put her back down in the crib.
Oh my goodness.
So that was quite a shock, if you like.
Yes. Wow. That she's holding herself up.
She's holding herself up. She's got her little hand hanging around there.
Wow. Oh my goodness. All right. That's wonderful. Good. Let me ask you one more. What advice would you give to young people thinking of entering the computing, we'll say the computing field?
Well, the one really unusual thing I did was mix business school classes with engineering classes. And I fell into it. I think it's worthwhile for people trying to get a course in economics, a course in accounting, as part of your engineering education. A course in marketing, it could be a course in market management.
Mm-hmm.
Things which are skills that can be very important or can be critical to your success, or your company's success and what you're doing for them. So, and I think that one of the things that we're here today is because of the National Medal for Technology and Innovation that I won. I'm one of the few people in that group who was not a PhD. I say, well, that's really for engineers, because engineers have different requirements than scientists do. Scientists don't very often have to worry about accounting or marketing strategies or things like that they get with some management courses. So people ought to think about training themselves not just as scientists or just as engineers, but as people who have to live in an organization with people and their people problems along with their technical problems.
Okay. Good. Good. I have to ask you this question. one more generic question. What contributions to computing are you proudest of?
Well, I think the most interesting, maybe most significant contribution came at the time the disks had physically arrived. People could store things, the costs were coming down, and that the whole new world of things, if you could have a shorter and shorter response time from the computer action you were working with. And IDS provided the means you could get some very short response times to problem solving. So we were running transactions, some which might be just a few seconds long. Other words, it could be mixed in with things that might take minutes. But in the transaction world, you don't want anything that takes an hour. If it's going to take an hour, you want to find a way to break it up into pieces. What you could with the problem controller we had, you could break it up and have each piece leave it a message for the next piece to start up. So you could break it in a vertical sense as you progress through time. So I'd say the best kept secret is the problem controller part of the system. And I like all parts of it. You know, one thing I brought here, something I want to show you.
All right.
Would you bring that box, not white box, that's a blue box.
Happy to. Shall I open the box, or do you want to open it?
Let's bring it here. Is the camera running?
The camera is running, but I need to broaden out the so people can see the box. They're just seeing your head right. So, let's go. All right, there you go.
Well, this box, if you look right close, it says it's Tiffany box. Now, Tiffany is not just my opinion, but other people think it's one of the best jewelry stores in the country, in the world. And in here, is a nice shiny bowl. And this bowl on here says, if I switch around here quickly, it says Charles W. Bachman, ACM Turing Award, 1973. Well, this was one of the thrills in my life, to receive this silver bowl as a gift from the ACM and for winning the Turing Prize. Now, the thing I think is interesting, it makes this thing consistent with the computer world we live in, and this is the fact that I also won a monetary prize of $1,000 for winning this prize. And if you this year, if you win the prize, the Turing Award, the prize is $1 million. It just shows that the prize of money takes the prize for the what's the word I want to say?
The prize for the award?
Oh, I mean
the Moore's Law?
Moore's Law, yes.
Yes.
Gordon Moore, for how things grow
exponentially?
Exponentially in terms of speed and reduction in size and cost. Well, that's gone from $1,000 to $1 million, but this is the same loving cup.
The same bowl they give today.
Same old thing as today, and some people say that's a Revere bowl. First done by Paul Revere of Philadelphia and Boston.
Right.
So thank you very much.
Okay. Good. Now, at some point, you move from working for the in New York City for GE's not overall corporate organization to moving out to Phoenix for to join the computer division.
Right.
Could you just tell us a little bit of the story of how that happened? What was that transition? How did you end up there?
Well, if the integrated data store was going to become a product, it had to eventually have to be owned by Phoenix and the computer department out there.
Mm-hmm.
So it was a matter of when is the right time to move. And we had a neighborhood situation where the man next door had been threatening his wife with a gun, and my wife wanted to get out of there.
Okay.
So we probably moved faster than we would normally.
So Connie was a little bit of an incentive there.
Well, it was a big incentive.
Okay.
She wanted to move.
All right.
So we moved that summer. And I think it was slightly premature from a best yield product-wise,
Mm-hmm.
because I lost control over the 200 line and never gained control over the 400 or 600 product lines.
Okay.
So I had to go out there and find a job for myself.
Ah.
And which most of the time I spent for a while, a couple of years, was trying to promote IDS to the industry on the assumption of if we couldn't patent it. In fact, we had inquired to the GE patent department, and they said, well, the patent department doesn't patent software these days.
Yep.
So,
It took them quite a while to eventually come around to doing that. Yes.
well, they came around when the Supreme Court told them to do it.
Yep.
And it turns out that there were two patents that the same Honeywell attorney had submitted, and both have been rejected as being software.
Mm-hmm.
And he picked one of them, which wasn't mine. The other one was mine.
Okay.
Or I would have been that guy's name on that patent, which I would have delighted to have had happened.
Yes.
But this lawyer, his name I can't remember at the moment.
Wasn't Regan, was it?
What?
Regan?
No.
No, because there was a patent lawyer at Honeywell by that name.
But who had a habit of making several disclosures of embodiments of the patent. And he would do a hardware embodiment as well as a software embodiment on the assumption that you're not patenting an embodiment, that's an example. So he wanted to get an example that was legal and had been approved for a software patent, for a software embodiment.
Mm-hmm.
And the Supreme Court ruled on his behalf, and we all got our patents by and by. So, but that time went by the time when we were. So I said, well, there's two things you can do with this thing. You can either turn it loose, or you can get everyone to try to get it established as a national standard. Then you have a whole bunch of field people who know how to use it and sell it, and the rest have to catch up with you.
Mm-hmm.
So as long as we're not going to be able to control it, let's see if we can't get it approved as a codicil patent. And we went through several years of work with committee meetings every 2 or 3 months, and finally IBM put enough weight on that there's no way we'd get it passed as a codicil standard. And so that just kind of petered out.
Oh.
So that's the way that went.
All right. So you spent couple of years out at Phoenix working on that?
Yes.
Yeah.
And I think that someone, in fact, in the papers for the National Medal for Technology and Innovation, one of the recommendations listed, I think, 10 or 12 different companies who had embodiments of ideas that they used.
Mm-hmm.
So that it got broad use, plus the IBM through IDMS. So it got spread across a lot of people.
But GE never made a huge amount of money.
I would say they stayed in business longer than they would otherwise.
All right.
So I say they made a lot of money.
When did you move to Phoenix?
The summer of 1964.
All right.
We were out there until summer 1970, after Honeywell had bought, or after GE had sold themselves to Honeywell.
Yes. Okay. Were there any other interesting things that you managed to work on while you were out at Phoenix, besides this codicil effort to standardize?
That, and also I was working on the communication-oriented extensions in the opposite direction of the database, which was data storage and retrieval.
Mm-hmm.
So I've been looking for ways to expand the programming world in the same sense there would be a set of commands and descriptors and whatnot to let people do computer-to-computer order processing and whatnot. There was a lot of work going on at that time about computer-aided business, business or between businesses,
Mm-hmm.
business-to-business communications.
Okay.
And so I was putting my effort in that at the same time. And then we got into the thing through where the British thought we should have an international standard for computer communications. And they're the ones who stirred up the interest that led to the creation of the ISO, International Standards Organization, Subcommittee 16, with the responsibility for computer-to-computer communications.
Now that didn't happen until after you became part of Honeywell, right?
That's right. It was activated after Honeywell got involved with it.
Okay. So in 1970, after the acquisition, did you move? Is that when you moved to the Boston area?
Back to Lexington then.
Okay.
And the kids all said, this deal came up about the pending merger. It came up in the spring.
Mm-hmm.
With something that said that it would be finalized on the 1st of October. And the kids all said, we've been moved enough times here. If you can't be there by the first day of school, we're not going. Because if you don't get there the first day of school, you're a new kid all year.
Yes.
If you're there the first day of school, you're just one like everybody else.
Okay.
So in fact, I moved the family back here before the merger was finalized.
Mm-hmm.
Having talked to the people here at Honeywell, because Honeywell headquarters are just they're very close to where we are now.
Mm-hmm.
They're just down the road. Did you come in here by way of
I came in down Trapello Road.
Trapello Road, okay. Well, the next on the road, just beyond that, No, you came Trapello Road,
Right.
not Totten Pond,
No, not Totten Pond.
Trapello. Anyway, right straight through here to the west is where was the Honeywell's computer business centralized.
Mm-hmm.
Well, you've been to that location.
Yes, I remember. They were. Well, there were certainly some main offices in. I think they were. I think it was. Were they in Wellesley? Yes, on
The
Route 60.
marketing offices.
That was marketing.
That was
Yes.
marketing in Wellesley, there by the Pillar House.
Right. Yes. Exactly. Yeah, I remember that.
I think that's where I met you down there.
That could be. I think that's when. That was after Honeywell. Well, actually, yeah, you may have met me down there, but Honeywell bought Computer Control Company in the mid '60s.
Yeah.
So that's when I first, spent some time down in Wellesley. So anyway, so you came here, and so what were you going to work on?
I work on the communications.
You decided to continue working on communications.
That was what was a missing piece,
Okay. Yes.
at least from my point of view.
Mm-hmm.
And so I managed to stir myself into the mixture.
Yes. Now, who did you end up working for when you came here? Was it the same GE group you'd been with in Phoenix and they got transferred, or was it?
Well, no, I was the head of a group of software people
Okay.
who came here, and we worked in the software department.
All right. And these were people from GE?
No, well, I brought a group with me from Phoenix,
Yes. Okay.
but the man who I worked for, well, the man I would have worked for died suddenly.
Oh, my goodness.
I forget what his name was. He died even before I got here.
Okay.
And another, I forget who the man who took over, but who was in charge of all software.
Hmm.
And there was a new product line going on at that time. So there was software for the new product line,
Oh, yes. They were trying to invent a new product line.
NPL.
Yes. And there was a Italian fellow, Ugo Gagliardi.
Gagliardi, yes.
Yes, who was, I think he was in charge of that in some sense.
Yeah, he was there. In fact, I worked for him for a while.
Okay.
In fact, he's the only man I know of who reduced my salary.
Really?
He said, "You and Jacques Bouvard are both overpaid."
Oh my goodness.
He cut both our salaries.
Wow. Now, was Jacques
Jacques-
native to Honeywell?
Yes.
He'd been there before. Yes, he was there when you arrived. He was
Yes.
not a GE transplant. Okay. All right. So did both of you work on the software?
Yes.
Did you work on NPL or,
On the new product line, yes.
Okay.
Phoenix was involved with this too,
Mm-hmm.
because Phoenix is going to be they have three sizes. Boston got the medium-sized machine. Phoenix got the big machine. And I guess the small machine was divided between Paris and Milan.
Okay, between Bull and, yes, Milan. Okay. All right.
And so that went on for a while.
So what happened there?
Well, what happened there?
Yeah, what happened to that project?
Things just kind of bubbled along.
Mm-hmm.
And what? Well, I guess in the end, there was they created advanced research group, which Jacques and I were in, which Ugo was in charge of. Well, but between us and Ugo, there was an Italian man whose name never is lost.
Okay.
Or I should say, I can't find it. That's what they say. You don't lose names, because when you hear it, you say, sure, that's the name.
Right.
It's just that you don't know how to locate it.
It's a search mechanism
Yes.
problem, not a memory problem.
Right.
Okay.
But eventually, after about 10 years with Honeywell, I said, it's not going anywhere. We had some new ideas out on the table, but they weren't going anywhere. In fact, I was never very good at selling up in the management. There are all kinds of opportunities I could have gone and sat down with management and even been thrown out the door. But I was too passive, I guess is the word.
Okay.
So there are opportunities that I had that I didn't recognize then or maybe ever. They came and went.
Mm-hmm. Do you have any examples of those that come to mind?
Well, I think the most important one is the one about the problem controller. That there was because GE was saying that we have three-dimensional system. We do time sharing, we do batch, and we do something else. I forget what, 3 different dimensions. Well, transaction processing would be a highly qualified fourth dimension, which would have made a good marketing spiel about four-dimensional systems.
Yes.
And people desperately needed a transaction control system.
Mm-hmm. Okay. And
And I worked on the international thing for the last 3 years I was with Honeywell. And I worked on it for a year while I was at Cullinane
okay.
as part-time activity. Then I decided this is not in Cullinane's best interest to spend my time here, so I resigned the position, which as a chairman of the group, I would have been automatically replaced at the end of 5 years, 5-year term.
Mm-hmm.
At the end of 4 years, I thought that time to go now.
All right. Let's talk some more about that. Let's roll back on. I think you're speaking of your chairmanship of leadership in the OSI.
Yeah.
Development of the OSI model for computer-to-computer communications. Could you go back?
Seven-level architecture.
Yes, yes. Could you go back and tell us the story of when you first started working on that or thinking about that at Honeywell, and then the story about it moving to a standardization sort of process? Yeah. And how you became the chairman.
Well, when I was working with my own definitions about adding on communication extension to COBOL.
Mm-hmm.
And someplace along the line, I saw IBM presentation of their 6-level architectural structure for communications, which was very similar to the one I have been constructing for Honeywell.
This was SNA?
Yes.
Yes, their system network architecture. Okay.
Now, SNA had some fundamental problems. First of all, it was a hierarchical system and not a network system. I always assume someplace there's a mainframe which controls all this for company A or for company B.
Mm-hmm.
Also, one of the things that we haven't even talked about, it came from IDS, is it had a what we call a level of data independence. So your program you're writing may have a certain view of what information looks like, and somebody else's program has a different view of that. But there is a canonical form which is in the database, and so you can define how each of these maps onto the canonical form, so that you could bring in something that's already existing, and as long as you can map it onto the canonical form, you could make it compatible. When you move the data into your working storage, it would be reformatted to be compatible for that program.
Mm-hmm.
Well, the IBM 6-level architecture did not have a data independence level. And my thought, well, this is just exactly the same kind of thing that we had in IDS. It had the ability that you have two different things that you know in terms of a canonical form, that you can transform one into the other.
Mm-hmm.
In fact, in the group working at Honeywell, we at a committee carry out of the coastal group that was looking at how to handle the problem of data independence. And the general picture we had was that you got somebody sitting at a terminal with one view of data, accessing data which is in another representation of the same information. Then we should be able to, if I have the mapping of these two both onto the canonical form, then I can transform from one to the other.
Mm-hmm.
And so I said, well, let's just move that layer over into what IBM's doing, because the basic problem is every place around. And there was a report out written by a computer science professor up in the University of Montreal on the solution that our committee created for data independence. So that was part of what I thought I could add, in fact did add to my, now 6 level became 7 levels.
Mm-hmm.
And I said, I accept what IBM has said for the other levels, as long as they all work together and this data independence level fits in here. And you can either implement it so I can convert it to the receiving end or the sending end, or someplace in between, depending on how you implement it. But at least intellectually, we know what has to map onto what.
Yes. Okay.
And so when this proposal came out of an Australian meeting of the TC 97, Technical Committee 97, I think it is, to create a new SC 16 to do the communication standards. And it was voted on, well, as one man who was here in Lexington now, John Day, who I see quite often, who was on that international committee and stayed with it and is still actively pursuing the longer term view that we worked on, in contrast to what the current internet is.
Yes.
In fact, as someone said very carefully, the internet is a uninet because it only supports one network.
Right.
Doesn't support any other networks.
Yeah.
Where the 7-layer model did have a node-to-node conversion between 2 layers. I mean, between the two networks. Again, based on some canonical form, but translate from one to the other. But maybe it's only the control characters you have to change, or at some level down, maybe it's just, you don't have to play with the content of the message.
Okay.
But at least you had to gain control of it. So there's an ongoing effort right now to resurrect some of the DC-97 work coming out of Europe,
Okay.
and a lot of that work came from Europe in the first place.
Right. Right. So going back though to this time at Honeywell, I understand what you sort of the work you did a little bit at Honeywell. Now
We're working with the committee. Well, as I said, at a certain point came that I could see that Honeywell wasn't going to do anything about it. They didn't do advanced database implementation, and really would not have their heart in communications.
Yes.
I said, well, I'll go see if I can get a job with John Cullinane.
Well, can we go back? I mean, you're skipping ahead. I want to hear about how you got on the OSI committee and what you did there.
Okay, you want to hear that again?
Well, I want it on tape.
Yeah, okay.
I've heard it before.
Okay, very good.
Yes, there's sort of two issues here, whether I know it or
that's true.
we have it on
tape
tape.
Doesn't know it.
Yes, exactly. Thank you.
Well, I heard about this new committee coming up, and I inquired around Honeywell up at corporate headquarters where this issue would have been talked about. And they said they were not going to support it because they were not interested in that communications. Now, at what level up there they decided that, or who all agreed with that, I don't know. But there existed a man named Warren Simmons who worked for U.S. Steel, who was one of the old Codicil committee members, and who'd also been chairman of that extension of the Codicil committee that tried to standardize IDS and could not get a majority on it. And I called Warren and said, Honeywell's not going to support this activity, which you're interested in, but if you got me appointed chairman of it, I don't think they'd have the guts to say, no, you can't work on that. As it turned out, I forecast correctly. They wrote me a letter, offered me the job if I could find time to work on it.
Yep.
And I passed the letter back up management levels at Honeywell, and they said, okay, you can, that's all right. That's in Honeywell's interest to have you there. Assuming they felt they could control me and therefore control the committee.
Right. The first premise might have been a little off.
A little off.
That they can control you.
Well, I thought I was doing what was the best in Honeywell's interest.
Absolutely.
And I knew more about it than anyone else did.
Especially people in Minneapolis.
Yes, staff people there are. Well, probably the man who said Honeywell wouldn't do anything about it was probably the most right. Because they didn't do anything about it.
Yes.
They were trying to get themselves out of the business.
Right.
And take as much money out as they could at the same time. But anyway, I was duly appointed, first of all, as the chairman of the American Committee working on it. So that when they had a meeting of the international group all in one place, I wouldn't be chairman of that group till that group appointed me to their chairman. But the American group could appoint me head of the American group. And so I wrote one more draft of what I've been working on for Honeywell and made it more neutral sounding. And this is the American position now, it's not a Honeywell position. And which was quite thorough and quite complete. And so everyone got together and said, this is the best draft we've got. So they accepted that, which they wanted to do some work on, of course. everybody wants to put some of their own love or truth or whatnot into every standard.
Absolutely.
They want to make it their own.
Yes.
But we made it our own, the American proposal. And then at the meeting, we got together and voted on it and accepted it. And got myself appointed as chairman of the American ANSI group, American National Standards Institute, which is the American side of the standards.
Mm-hmm.
And then at the international meeting, everyone provided their drafts from their country. And the American draft was one other thing I need to back up.
Okay.
One of the rules in that ISO
Yes.
is that whatever country is going to be the rapporteur, the official secretary for an ISO committee, has to have the chairmanship too,
Mm-hmm.
which is probably good practice.
Mm-hmm.
So that the meeting in Australia had appointed the American ANSI as the official reporter of this new committee. Chairman unknown, but
Mm-hmm.
and therefore, having gotten around and America said, okay, the American Standards Group chairman is Charlie Bachman, then he obviously ought to be the ISO standard, so we don't have any conflict up here.
Right.
So I got appointed chairman of the ANSI group and the ISO group.
Mm-hmm.
And started on several years of world travel and trying to perfect this written specification.
And negotiate a compromise that would.
And along the way, I tried to introduce into this specification data structure diagrams as part of the formal specification.
Mm-hmm.
And it went in, the next meeting it went out. The next meeting it went back in again, then it went out. So it never ended up in the final report. But one of the things that you get side effects. I had a group of delegates from Japan that were in a meeting, and they said the data structure diagram has boxes and lines.
Mm-hmm.
And it turns out a box looks like 4 lines. So they said, well, why don't you put a little extra line around 2 sides and make it a shadow? Because boxes make shadows. Lines don't make shadows. So that when we got around to, we drew all of our entity boxes with a box with a shadow on the right side and across the bottom.
Okay.
So it very clearly made a distinct symbol out of the box, where before it was confused with four lines.
Okay.
So thanks to the Japanese, we have shadow boxes. But that went on for 4 years.
Mm-hmm.
And at the last meeting, we took the draft, which had come to the meeting, to Paris. I don't forget where the prior meeting was, but we did some little trimming here and there, got it retyped, what needed retyping, and then we all piled into a douze-chevaux. You know what a douze-chevaux is?
No, I do not.
That's a 2-cylinder not Austin car,
Renault car?
Renault.
Yes. Yes.
It's one of these canvas top things.
Uh-huh.
to drive down to the IBM office so we could duplicate the copy here, so we could all take home copies that had been signed
Okay.
as an accepted standard. That was a big point. I think we had 7 people in that deux chevaux, which is probably good for 4 people.
Yes, that must have been fun. Funny.
I think deux chevaux means 2 valves,
Okay.
or 2 cylinders.
All right.
It was really it was the lowest price car you could buy in France,
Okay.
but it was transportation.
Mm-hmm.
And it was shortly thereafter that I had a meeting in Tokyo that I resigned my position as chairman to go back and spend full time working for Honeywell, for Cullinane. And I shortly after got laid off by Cullinane because they felt they had to put a relational database out. They couldn't imagine me helping put out a relational database. Although this brings me to missed opportunities
Mm-hmm.
that you'd asked about earlier. Well, one of the things that I had observed when I was in Phoenix a couple of visits earlier in this is that one of the men out there who had worked on the relational database system for Multics
Mm-hmm.
had found a way that he could take a relational query and translate it in an automated way into a IDS program.
Okay.
And in fact, he explored moving back and forth. He said there's a great deal of similarity, difference in style, how you do it. But the objects they're dealing with can be considered the same. Records and entities are the same thing. They have primary keys. We don't talk about primary keys, but we have primary keys. And so he had a demonstrable package of this that ran in the 600.
Mm-hmm.
That he was in the advanced research group in Phoenix. And that wasn't going anywhere, and I knew about it, and I wasn't smart enough to suggest to John Cullinane that we know the solution to your problem. People want a relational database, but SQL is just SQL query language.
Yes.
It's a query language, it's not a database system.
Right.
And so people have been struggling to try to find a database system to fit under it.
Mm-hmm.
And I said, well, all we want to do, being SQL compatible is what our goal should be. So you can say, you want SQL? Sure, here's what you type into the terminal, and you're into the SQL world, and you can run it against your existing databases.
Mm-hmm.
Or against separate databases when you want to.
Right.
And if I had been clever enough or subtle enough or smart enough not to be prejudiced against SQL and said, what's the opportunity? If I had been an independent contractor saying, what do we do?
Yes.
And knew to say what I knew, I would have said, you should put an SQL front end on IDS.
Well,
Never passed my mind. I'd seen it demonstrated, it worked.
and it still didn't.
Well, people get prejudiced about things.
Yes. Okay.
And I didn't stop and say SQL is, what's SQL stand for? Query language.
I want to say system query language, but I don't know that for a
Doesn't
fact.
sound right.
That it
Anyway,
probably isn't.
It would have been a a beautiful solution for John Cullinane because it would enhance his product offering. He could charge more because he got this extra interface you got to buy if you want it. And instead of falling on his nose, because people stopped buying IDS because they wanted SQL.
Yes.
Well, you want to sell them SQL with IDS
Right.
for a higher price.
That would have been good. Definitely.
And he could have gotten there before, and IBM didn't go the other way. They just waited until, it was 20 years later after IDS was running before they had DB2 as a mainframe product.
Mm-hmm.
So there's plenty of time to maneuver in there.
Yeah. Okay.
Structured query language,
Thank you.
SQL.
Yes. Good. Very good. Good recall.
Yes.
The search mechanism worked.
It worked, yes.
Good. So you stayed for a while at Bachman, and then Bachman. Then you left. You weren't really not at Bachman, at Cullinane. I'm sorry, using the wrong words. So what did you do next? Where did the idea for starting your own company come from?
Well,
or how long had you been thinking about that?
Well, I'd been thinking for a long time about wanting to have a computer-aided design tool to help people draw data structure diagrams. And more important than drawing them is being able to modify them.
Okay.
Not having to redraw them all over again.
Right, okay.
Because people have been drawing them with pen and pencil for 20 years.
Mm-hmm.
In fact, I've seen huge rooms with all the four walls, all just one big diagram at Boeing aircraft.
Okay.
And so I'd always been kind of working on the side, how do we do this? And I've been spending some of my time actually at Cullinane trying to build an automated data structure diagram for their business.
Right.
Because their customers could have used it.
Mm-hmm.
But they decided that their need for SQL was more important than their ability to do data structure diagrams. So when I left Cullinane, and they were, I thought, generous enough to give me a sizable, they didn't give me a lump sum payment, they gave me a consulting contract for over a year at a rate that I could live comfortably and have some money to do some development work. And so I left almost immediately after, on April Fool's Day. We incorporated Bachman Information Systems.
Okay.
Which started out myself, then I hired my son John, who was selling automobiles then because the chemical business was not hiring. As a chemical engineer out of school, he could not find a job in his field.
Wow.
He came to work for me. And then we got a contract with a Norwegian really consulting firm that did some operations work for other companies, and also had people they hired out in a traditional consulting way, doing IDS or IDMS consulting.
Mm-hmm.
They gave us an extra $5,000 a month revenue, and I told John that I could pay him enough a month to handle his social requirements, to keep his girlfriend happy and keep him happy with his girlfriend. And he got engaged at that period of time, by the way.
Oh, wow. All right.
It was serious. And so he came to work for me, and we started working, and we made 4 or 5 trips to Norway, and their group came over to visit us in Boston and Lexington, trying to construct something that would help them in their work with ITMS. And these are people I had met through the Cullinane European user meeting.
Mm-hmm.
And so that kept John and hired, and we were struggling because we were being charged by a company out here west of town. And we found out their bills didn't reflect what came, the end of every compilation, for example, it would print out the time and charge.
Yeah. You were using a service bureau.
Service bureau, yes.
Yeah, sure.
But they said, well, there's some other bills you're not seeing on that listing. And I said, why should I pay a bill that I'm not seeing? And you tell me I owe you $40,000 now.
Yeah.
And so we went back and forth, and instead of being smart and just not paying them and letting them do whatever they wanted to do about it,
Right.
I somehow peeled down into the savings and wrote them a check for $40,000,
Oh, wow.
which left us in pinched conditions.
Uh-huh.
At which point we were put in touch with some venture capitalists. One of the people who had been at Cullinane and had sold Cullinane his product company said, well, I can help you with Venrock, which is the Rockefeller Family Venture Fund.
Okay.
And
Who was this? This person that had sold his company to Cullinane and then
I can't think of the name at the moment.
Cooper?
Yes,
Yes. Okay.
Phil Cooper.
Phil Cooper. Yes.
Yeah, that's exactly who it was.
Yes. I know Phil Cooper.
And he also was at an inn with Hunter Perkins, Caulfield, and Byers,
Uh-huh.
people who had loaned him money for his company.
Yes.
And so he put us in contact and helped us package it up, so we were able to get some venture capital funding for them,
Okay.
and got us so we could move out of our house where we've been working
Mm-hmm.
and move down into not Kendall Square, but down closer to the bridge.
Yes. Somewhere there.
He was in one building, and he had some extra space in that building for a while that he rented us, so he's cut his costs. And then we got too big for that area. We took a space out at the Burlington Mall.
Mm-hmm.
There's an industrial park out there.
Okay.
And by that time, we needed 2 floors.
Mm-hmm.
And we're growing.
And you were still working on the design tools for.
Yeah, in fact, the entire period of time that Bachman Information Systems existed was all computer-aided software design tools for database design, for communications, for process control.
Okay. All right.
And, one important thing that I don't think anyone ever whispered to me or even shouted at me about is that one thing you're supposed to learn is that you're supposed to spend less money than you make. And if you spend less money than you make, you'll just do fine forever. But if you're saying, well, I've got to grow this product more, I got to add more parts on it, after you put on 3 or 4 porches and whatnot, all of a sudden you're short of money. And the next round of money you raise, you get less money for your shares.
Right.
And we went through several rounds of shares that way. And also we got to the point where they didn't want shares, they wanted what kind of shares are
Preferred shares.
preferred shares.
Yes.
So they wanted to get paid whether the rest do it or not.
Right.
So we had a couple of rounds of preferred stock. But now I should tell you, I think we had something like 8 or 9 quarters of profitability in between.
Okay.
So at one time, our market share, our market valuation, was $1/3 of $1 billion. But I couldn't sell stock.
Yes. Right, because you were locked up. Yes.
I was locked up.
Of course. I know.
So my career with them lasted 14 years.
Uh-huh.
And it was an interesting 14 years. Exciting, kept me alive and well, and well paid,
Uh-huh.
and sold a lot of versions of the data structure diagram drawer.
Uh-huh.
So it was a good idea. It kept us away from the red line
Right. But
for 15 years.
that's pretty good.
Long enough that we could buy a house and retire and buy a house in Tucson, Arizona,
Uh-huh.
and then sell it for twice what we paid for it.
There's nothing wrong with that.
So by the time we put that money in, the other money we've been saving, we had a lot of bond stocks.
Uh-huh.
I mean, shares of bonds we owned,
Yes.
mostly government bonds,
Uh-huh.
which is taking care of us to get us here.
Okay. Good. What happened in the end to Bachman? And the business of, the tools that helped you with data structure diagrams.
Well, the tools, because that people's work habits changed. They weren't designing big databases anymore.
Ah.
And so that the structured back to the words I can't remember. We said structured query language, SQL.
Yes, SQL.
People were doing smaller things, quick and dirty, where they weren't investing in long-term production of a database. And performance was not important,
Right.
or didn't have the same level of importance. And also, processors were faster and cheaper,
I was going to
memory
say
larger.
Moore's law was meaning you could use less and less efficient software
That's right.
technologies and still get the results you needed for the price and speed you needed.
Yes.
Yes.
So
Sloppier and sloppier software
That's
still
right.
worked just fine.
it still worked, absolutely.
Yes.
And it was the right solution for the customers. I don't fault them for doing that,
Right.
because they wanted results.
It was
People wanted their results faster and faster too.
right.
They didn't spend 2 years on a system or 3 years on a system.
Right. And that's why the relational model became more popular, because
Yes.
you didn't have to do all the planning that you had to do
Right.
with
Well, it turns out, people keep telling me that the thing you're missing, Charlie, is looking at the database manager's add-ons. They go in behind what you do with your SQL. You can declare something, but they'll set up what the indexes are and whatnot. So you get things that are very much like IDS behind the scene.
Uh-huh.
Because if they know this is a big operation, it's going to go for, they will invest time in packaging the actual storage for performance reasons. Even behind the scenes on something which apparently has no storage structure.
Yes.
The query user doesn't have to know about it, because it'll run faster or slower depending on how well the database administrator has made his contribution to the definitions.
Okay. Good. And so is the structuring product still available? Does somebody still sell it?
No one's selling it anymore.
No one's selling it. Okay.
I'm still using it. I give it to people.
Yes. You should make it shareware. Yes. Be available. What happened to the company? It got bought, didn't it?
It got bought by the Texas people who eventually got bought by Computer Associates.
Ah. Okay. So it ended up at Computer Associates.
Ended up at Computer Associates.
Okay. Yeah. Well, that wouldn't be the worst place, because they also, as you just mentioned a few minutes ago, they support an awful lot of legacy databases.
Yes.
Yes. That are hierarchical and can use,
Well, there apparently are a lot of tools out there that do things very much like data structure diagrams. Peter Chen, for one, has made a reputation for himself for a slightly different version, and has won a lot of prizes for himself.
Okay. All right. Okay. So there's still people
Out there, yes.
doing, yes, trying to solve the same problem you were.
Right.
Right. Do you have any other things that the things you'd like to leave with our viewers or our transcript readers before we end this
I think
interview?
I'm pooped.
I think you've done extremely well.
Well, I thank you for that.
Okay. Well, thank you very much, Charlie, for taking the time and the effort to go and do this. It's been wonderful.
Well, it's been a fun experience. I don't think it was being work. I just think it's been exciting.
Okay. Good. Well, thank you on behalf of the Computer History Museum.